This is the last and final video for section 3.3, and in it we're going to cover example 3, which is the last type of integral. These are ones where we have a constant squared plus x squared. And so that's what you see here. We have the integral of 1 over x squared plus 1. And we're going to go back to the warm-up here real quick. So this is going to look more like example B from the warm-up. We have something squared plus tangent squared. And because of that plus, right? So something squared plus a function squared. And so in order to make this work, we want to have tangent, because 1 plus tangent squared theta is equal to secant squared theta. So remembering that, we're going to use the fact that 1 plus tangent squared theta is equal to secant squared theta. Okay? So I'm trying to evaluate integral of 1 over x squared plus 1. And in order to do that, we're going to, again, take advantage of this identity, which means we want x to be equal to what? What do we want x to be equal to for this problem? We want x to be equal to tangent. We want x to be equal to tangent theta, which means dx is going to be the derivative. It's going to be secant squared theta d theta. And simplifying now x squared plus 1, that's going to make this tangent squared x plus 1, or not x, but theta. Tangent squared theta plus 1. And using that identity, that simplifies to secant squared theta. And so we have everything we need to do now. This is actually a really easy example. They're not all this easy, but we like it when they are. So go ahead, if you haven't done this on your own yet, go ahead and pause the video here real quick and write out what you think we would have after making the substitution. Okay, welcome back. Hopefully you were able to write that out. In the denominator, we already found that x squared plus 1 simplified down to secant squared theta. So we have secant squared theta in the denominator. And then we also found that dx was equal to secant squared theta, d theta. And so it works out very nicely that the secant squared thetas divide out. And we're left with a simple integral. It's just the integral of d theta, which we know is theta plus c. And we know what theta would be equal to. We know, using inverse trig functions, we know theta is equal to the inverse tangent of x. So this is the inverse tangent of x plus c. And that's going to do it for this video. Thank you for watching. I'll see you next time. Let me know if you have any questions. Thank you.